In this video, we want to investigate the equilibrium bidding strategy in a first price sealed bid procurement auction. We start with supplier I's optimization problem and by writing down supplier I's expected profit. The expected profit of supplier I when placing a bid B is given by the profit in case of winning, which is nothing different but the bid minus the cost of supplier I times the probability of winning with bid B. And the probability of winning with bid B is just the probability that B is smaller than all competitors' bids. Let us assume that I's competitors are following some monotone bidding strategy beta of C. Okay? Then the question of asking in which case does a supplier place a bid of, let's say, beta J is equivalent to the question of what is the case for supplier J of having costs of Cj. Okay, so the probability that my bid is smaller than the bids of all others is equal to the question of what is the probability that all others have costs such that they place a bid that is larger than my bid. Okay? Let's illustrate this with a very simple example and assume that the others are following the bidding strategy of 2/3 plus 1/3 times C. Okay? Then B is smaller than beta of C exactly in the case where B is smaller than 2/3 plus 1/3 times C, or 3B is smaller than 2 plus C, which is exactly the case if 3B minus 2 is smaller than C. Okay? And that's what we do here. So here we are in the bid domain. Here we are asking about events for bids. And here we ask about events for our competitors, exactly our strongest competitors' costs. The next step is quite easy. The probability that the cost of the strongest competitor are larger than beta to the power of -1 of B is, due to the continuous cost distribution, just 1 minus the probability that the costs are smaller than beta to the power of -1. And now we can basically just plug in. We said that the probability that I's strongest competitor has costs below X is G of X. That means the probability that the strongest competitor has costs smaller than beta to the power of -1 of B is just G of beta to the power of -1 of B. Now we have defined the expected profit of supplier I, and next we want to investigate what is the optimal bid that supplier I should bid. And to do so, we take the first derivative of the expected profit with respect to the bid to see what bid optimizes expected profit. To derive the first order condition, we obviously need to take the first derivative of the expected profit, and to do so we need to apply some rules. Here is an overview of rules that we might use for the next steps. So you can pause here and make yourself familiar with these rules. In our first step, we want to apply the product rule to get from here to here. Okay. The product rule says that the derivative of u v is equal to the derivative of u times v plus u times the derivative of v. Okay, so let's call this here u, and that is v. Then we get that u prime is equal to 1, and we get that v prime is equal to minus the derivative of g of beta to the power of minus 1 of b, like that. Okay, that means here we have 1 time v, and here we have u times v prime. And in the next step, we want to take the derivative of this expression. Okay, and to do so, we need to apply the chain rule. What does the chain rule say? The chain rule says that the derivative of u of v of x is given by v prime of x times u prime of v of x. Okay, and in our case we have that u is equal to g, and as a consequence u prime is given by the density, namely g, and we have that v is equal to beta to the power of minus 1, and here we just write that v prime is equal to the derivative of beta to the power of minus 1. Okay. That means here we have u prime of v, and here we have v prime. What is left is to take the derivative of this expression, and to do so we need to apply the inverse function rule. The inverse function rule just says that u to the power of minus 1 of x is given by 1 divided by u prime of u to the power of minus 1 of x. Okay, and if we directly apply that, then we get this expression. The next step is straightforward again. So what we do is we multiply both sides of the equation by this expression. And then what we do is we subtract from both sides this expression. Next, we want to utilize symmetry, meaning that we can write b is equal to beta of c, and for beta to the power of -1 of b, we can just write c. Okay? That means that someone who places a bit of b has costs of c. If we plug in c for beta to the power of -1 of b, then the expression simplifies and we get this new line. To get to the new line, what we basically do is we inverse the product rule. Remember, the product rule said that the derivative of u times v is equal to u prime times v plus u times v prime. And what we have here is that u is equal to beta, meaning u prime is equal to beta prime, and v is equal to 1 minus g, which implies that v prime is equal to minus g. Okay. So here we have v, here we have u prime, here we have u, and here we have v prime. Okay. So applying the rule, it is obvious that we get the equality of this expression and this expression. In the next step, we take the integral from c to c upper bar on both sides. Okay, so on the right hand side, we can just write down the integral from c to c upper bar of this expression. On the left hand side, we can directly plug in. We first plug in the upper limit, meaning c bar. If we plug it in here, we get beta of c upper bar times 1 minus g of c upper bar. And then we need to subtract the lower boundary, meaning c, and plugging it in, we just get beta of c times 1 minus g of c. Next, we use that g of c upper bar, meaning the probability that our strongest competitor has costs smaller than the highest possible costs, is 1. As a consequence, this expression equals 0. And what we can do then is we multiply with -1 and divide by this term, and so we get to here. This expression has a very nice interpretation, because this is this here is an expected value conditional on having lower cost than the strongest competitor. Okay, so that means the equilibrium bit is equal to the expected cost of the strongest competitor, conditional on this competitor having costs that are larger than our own costs.